All right, simplify each expression. Essentially what the rule here is that you're going to give the exponent separately to the numerator and to the denominator of each of these fractions. So, and I want to show you why that's the case. Okay, if we took the first one and we said, um, okay, 3/8 squared, what we're really saying is 3/8 times 3/8. And what that means is that you multiply top times top and bottom times bottom. So really what you get is 3 squared, because it's 3 times 3, over 8 squared. That. And you can see how that essentially is giving that exponent of 2 to both the numerator and the denominator separately. Okay? Now, these are numbers that we can actually calculate and solve. 3 squared is 9. 8 squared is 64. And that becomes what our final answer is. Let's keep going. A cubed, I'll write them all out. I'll say 1 cubed, and if there's more than one thing in it, or if it's a negative number or anything like that, it's really worthwhile to put parentheses around it. So let's say, sorry about this, just a little glitch there. 1 to the third power over a to the third power. Okay, 1 cubed is just 1. A to the third power is a cubed, and that's what you get for an answer for that one. Okay, let's keep going. You can see here, this is why we need to put parentheses around it, because both of those things are going to get raised to the fourth power, and that you will hopefully understand that this and this are not equal. Okay, because this right here in pink, surrounded in pink, is just 3x to the fourth. And watch what happens when it's in parentheses. It doesn't actually become 3x to the fourth. Let me get it out of there. And of course, I'll write over y to the fourth. But what do we get on top here? Well, what you're really doing is you're multiplying, or you're raising everything to the fourth power. So we've got 3 to the fourth times x to the fourth all over y to the fourth. And 3 to the fourth actually equals 81 x to the fourth. So if you didn't put parentheses around it, that 4 would only be raising x to the fourth power, and it wouldn't be raising the whole thing to the fourth power, and you need it to be over y to the fourth. There's that answer. Let's keep going. We've got 2x to the fifth over 3y to the fifth, which means you've got 2 to the fifth times x to the fifth over 3 to the fifth times y to the fifth. And 2 to the fifth is 32. X to the fifth is x to the fifth. 3 to the fifth is 243. And y to the fifth is y to the fifth. How did I know that it was 243? Experience, my friends. I've done that math problem so many times. The more comfortable you get with these numbers, the more you'll just be able to do them, because you've seen it, you've done it all before. Okay, right here, raising this to the third powers, you distribute that exponent to the top, and you give it to the bottom. And we've got 6 to the third power, which is 216, over 5 to the second power raised to the third power is actually 5 to the 2 times 3, or 5 to the sixth power. Okay, so then we get 216, and we get 5 times 5 is 25, 125, 625, 3125, and gosh, what would that be? 15,125. I got to do that math in my head over here. Let's do it. Okay, 5 times 5. Let me do it. 5 times 5 is 25. Another 5 times 5 is another 25. So if we multiply these together and got 625, we've actually got that. So far, we've done it 4 times. Let's do it 5 times. 3125. And let's do it another for a total of 6 times. Aha. So it is 15,625. Hard to do in my head. I'm not so familiar with that one. And that's it. That's how you simplify it. If you say, but Mr. Massey, how do I do that? Well, do it like I did it. Just do the multiplication out, right? Keep multiplying by 5. And long division should become something that you get good at. Anyway, that's how you do those.